Okay, we're centering up our magnet and we got slots, right, Jordan?
Mm-hmm.
See our moon-shaped slots? Our moon-shaped slots, go tip it back and forth for them. See how it goes, turn it one way or another like a steering wheel on a sled. Yeah, see that? Goes back and forth. Now he's going to center up the magnet. If he gets one way too far, it goes the other way, and he's going to try to get it center, and then I'm going to plug it in. He's going to get it right there. Well, close enough. I mean, we could do better. And now I'm going to plug it in, and there it goes. Did you move it? Okay. So there it goes, and it works better at a higher speed, of course. There it goes, and here's the amp draw. You can't read it. Amp draw fluctuates too much on this motor. You see that? I got a funny belt, and you can't read it. So I'm going to change this motor and belt so I can read it better. But one other significant way you could do is we could put he's holding it right now, but he could tighten that down. See, we got those washers on there. See that little washer? And we got the other one here too. We're just doing it like this for now to show you. And over here is our core, and we could wrap a few loops around that and hook it to a frequency counter or something. Get a magnetic shot from these, you know, and we could see the frequency change rather than change the motor. But I don't know how sensitive or accurate it'll be. I've got some circuits too that I could put somewhere and just put it over here. Put a magnet over. Let the magnet hit it over here on this side. Put the circuit right there, and it'll count how many times it goes around. So that's where we are right now. And I know what I wanted to say. Let me unplug this, and then that's all I'm going to leave you with today. But the magnet that's in there, Jordan and I worked on, is got stuffed in there with tape and pinched in. It's thanks, Jordan. It's shielded. This is shielded. If I didn't shield it, then the magnet would push away too soon. You see it push away there, but it would push away, and before this side actually attracted, it would push away. So by adjusting the magnetic shielding and pushing it out a little, pushing it in and out, I got it very close. And then the other thing is you got to have this thing perfectly straight in order to get cancellation, you know, perfect. But any amount is better than none, because look at all the lock there is. It's like huge amount of lock on there right now. It's like pounds and pounds of lock, and with this on there, it's barely a quarter pound sometimes. Depends on where you adjust it, but you want to adjust it on the fly. See, now it's there's barely any push at all there on it. Okay, that's it for now. We're working on brackets. See, we made an adjuster. We locked this magnet down and we also put the magnet inside of shielding, and we can adjust the magnet in and out too. I might put a little bracket with a screw, magnetic screw that pushes this out, because it keeps wanting to go in because it's repulsion side, so I can adjust it on the fly. And that's what we're doing. Jordan and I are working on bracketing and adjusters. And this is, I actually got started with this on listening to Mad Mac. I built this wheel because Mad Mac wanted us to measure minute differences in magnets. So that's what I'm doing with cancellation. Trying to cancel with two different sides is quite a feat. Now if you got identical magnets from an assorted pile here and there, and then on each side, in other words here and there, both on the rotor, and then identical magnets on the outside. And you, especially if you buy a lot of them and sort through them and find ones that are closer in strength, then it's real easy to cancel. Then everything is perfect. But when you have a block of steel, by the way, we changed our block of steel. See that? We did have this big fat short block. Now we went to a more narrow block. And the narrow block is smaller, a little smaller than the magnet, as you can see. And that helps, especially since it helps to the attraction to be less to the block by the time the repulsion side is repelling. So it balances out better with these current magnets. So that's what I'm trying to figure out. What's the best magnet against magnet and core block against magnet material, and making adjusters. Alright, thanks for watching. Bye. Okay, there is one other test we can show you, and this is the amp gauge. Now plug it in. I'll hold the now this is not very sensitive, this motor that's on here. To turn this is a 100 volt motor, and it's only running on 20 volts sometimes. It's not very sensitive, but plug it in, Jordan. See, watch the amp draw. See the amp draw go way up? Okay, unplug it. In case you didn't know, that was about 3,500, 350. Go ahead. Almost 400. What? No, 340. Okay. That's a dead lockup, and that's a 5 amp motor. All right. So that's why I used it, because it's not hurting it if we're holding the rotor down. Okay, now the rotor is got the new rotor block, core block on the magnet rotor there. There's a magnet. There's an identical magnet here and a small magnet shielded here with adjustables. And we adjusted it, and it's right centered. See that? Pretty centered. Okay, now plug it in. See it break the magnetic lock? Okay, you can't do it that way. You can't plug it in twice. Unplug it. Okay. Plug it in once, the first time. Ready?
Yeah.
Go. Okay, see it's locking a little bit. We need to move it in. Okay, take it off. But you'll see that it comes very close. Okay, plug it in again. Yep, it broke the lock. But the trick is to have the counterbalanced. Okay, do it again. Okay, we'll slow it down, and we'll get this magnet over here in the center. Okay, it's in the center here and in the center over here. See that? It's got to be in the center. Okay. See it? Broke the lock. Because it only needs, you can take it off. It only needs, barely breaks the lock with this motor, and it only needs about a half a pound of force to break it. Where it's, now I might be able to get it more perfectly centered, but that's pretty good. It breaks the lock. Now if I take this off, obviously it won't budge with the other one. We already showed you that. So you can see that it breaks the lock. And also, if you really look close on the amp draw, you can see it does drop with the it's hard to measure with that meter. That meter is too big, and this motor fluctuates so much that it kind of goes all over. All right. So anyways, what I want to do is put a speed sensor on it. next to see if I can measure any changes in RPM. Okay, thanks for watching.